Hello, sir. I think you are not audible, sir. Hello, everyone. Is sir audible? Hello, sir. I think you are not. Sir, please leave audio and again join. Sir, please leave audio and again join.
Yes, yes. Uh, yeah, guys. So can you check now whether the it is audible or not?
Sir, please leave audio and again join.
Yes, yes. Uh, yeah, guys. So can you check now whether the it is audible? Yes. So, guys, as you all know that your ATC exam is on the 27th of December, and we are planning to give you a boost in your preparation of ATC. So, those who have already prepared can take it as a revision session, and those who are not been prepared very much, that which kind of questions can be asked in this, you will see here in the today's session. So today I'm going to take the session on the electrostatics because we have 3 to 4 sessions here line up, and in this way we are actually going to cover up a maximum portion of the physics. So the in the electrostatics we have the electric charges and the properties that we are going to discuss. How do you charge it? What are the different methods of charging? And also along with that we will be having the Coulomb's law, right? So we will be having the Coulomb's law, and obviously in the Coulomb's law we will be discussing about the electric field intensity. So these are the electric field intensity we will get. So the topic I'm going to tell you here are going to discuss today, and along with the previous year questions, we will get that which kind of questions can be asked. That is also been discussed. So after that, we will also discuss about the electric field lines. So I will be keep asking you some questions. Those who are aware about these basic questions of electric fields, that they can answer those question also. Okay, and again their properties. So electric field line and their properties we are going to discuss, that which kind of line should exist or that will be valid, and that kind of, which kind of line cannot exist, these will be discussed. Then we have electric dipole also. So electric dipole we are going to discuss. Okay, then we have a different type of charge configuration, so we can say that the configuration of charges. Okay, configuration of charge distribution. So you guys can comment in the comment section that those who have already done some basics of physics for this particular exam. Just comment over the comment section so that I will get an idea that up to I have to go. Okay. Gauss law we are going to discuss. Application, obviously, Gauss law means we will also discuss some applications, potentials, work done. This will be the point of discussion today. Then we have a electrical potential or electrostatic potential, you can say, and some basics of the capacitor, energy density, etc. So these will be the topic that we are going to discuss. And obviously we will take some small questions of the previous year, that which kind of question is asked from these topics. So guys, what are the electric charges? What are the electric charges? How do you define the electric charges? It is nothing but an intrinsic property of certain particles like mass, by which they can interact with other charged particles. Okay, so how do you define the electric charge? They are nothing but the intrinsic property of certain particle. Remember that it is intrinsic particle of property of the certain particles like mass, by which they can interact with other charged particles. So that is the electric charge. What are their properties? So electric charges exist two different kind of charges, one that on the electron and another that on the proton. Right? By convention, the charge on the electron is taken as negative, and the charge on the proton is taken as positive. So we have the two type of charges. So the second thing we know about the charges is the like charges repel each other and unlike charges attract each other. And the third property we can say is the electric charges is conserved. Okay, electric charges are basically conserved, that is the total charge on the universe remains constant. And the charge, electric charge, is quantized. So in all the macroscopic consideration, charge always exists as an integral multiple. It will not be in the fraction, it will always be an integral multiple of electronic charges. So we define the charges as q is equal to ne, right? That is the number of charges. So we write q equal to ne. E is the uh, value of the charge, that is 1.6 into 10 to the power minus 19, and n is the number of charges. So if you are asked to calculate the number of charges, and if it is given the total charges, then you just divide it by the charge of the electron, then you can calculate the number of electrons. So this is the basic question that can be asked. Okay. And what is the value of electron? That is the charge on electron. So the charge on electron is E is equal to 1.6 into 10 to the power minus 19. So those who are not from the electronics background, they might not know, or they might forget. So that is why I am telling. Now the fifth property is the charge, unlike the mass, is invariant. Okay, the charge, unlike the mass, is invariant. It does not vary with the speed of the particle. So charge does not change according to the speed of particle. Then the charge cannot exist without mass. Charge will not exist without mass, and while the mass can exist without charge. Okay, anybody can be there without charge, but the charge cannot exist without mass, because definitely there will be somebody, we will charge them, so it will be having the mass and then we charge it. Charge is a scalar quantity, and the charge is always additive in nature. Okay, it is always additive in nature. So these are the basic properties of the charge. Now, what are the method of charging? So what are the method of charging? We can charge the any body, method of charging. Okay, so what are the method of charging? So the method of charging is the charging by friction. Okay, that is done. So charging we can do by friction. Okay, second, that two bodies are rubbed with each other. So there is a transfer of electron from one body to another. That is known as the charge by friction. When you rub each other, two different bodies are rub each other, then the charge transfers. Okay, so there are two bodies, and if you rub them, then the charge will transfer. The mass will decrease, and for when the charge will transfer, like here, if you will say this is suppose the body A, and suppose this is another body B, then we rub it, and then there will be a transfer of charge from A to B. Suppose the charge is transferring from A to B. If the charge is transferring from A to B, the mass of A will decrease, and because the charge has been transferred into B, the mass of B will increase. So mass decreases, and here the mass increases. Okay, so this is the charging by friction. Now, second example is charging by induction. Charging by induction. So, how do you charge by induction? So, when a charged body is brought near an uncharged body, there appears a charge on the surface of uncharged body due to the attractive or repulsive force between the charges. So the induced charge can be lesser or equal to the inducing charge. Induced charge can be less or equal to the inducing charge, and its maximum value is given by the maximum value when the induced charge is given by minus q of 1 minus 1 by k, where k is the dielectric constant. Okay, k is your dielectric constant of uncharged uncharged body. Dielectric constant of material of uncharged body. So that is your dielectric K. So how do you charge? So suppose there is a mass that is plus A. Okay, and there is another mass uncharged which is plus B. Sorry, not plus B, that is B. And suppose we bring them together close to each other. So this will remain in positive, and the surface which is near to this will have the charges opposite to that, so minus and plus. Okay, that is the minus, the opposite charges, and here it would be plus. The net charge should be 0. Here also it is neutral, and here net charge is 0. Net charge equal to 0. Now it will be like this also we can write, because it is like now minus, and it will become plus, and this one will become minus, and hence we can say that it is in grounded. So this is the two methods by which we charge. The method of charging means charge any body, uncharged body. If we want to charge, we can charge it by either friction or by induction. Now we will talk about the Coulomb's law. So what is the Coulomb's law? Okay, what are the Coulomb's law? So if there are the 2 point charges, okay, suppose there are 2 point charges, Q1 and Q2, and they are separated by some distance, let us say R. So what is the Coulomb force? The Coulomb force is nothing but the force of attraction. The 2 point charges and found that is varied inversely proportional to square of distance and directly proportional to the product of charges. If they are of the same polarity, then they will repel each other, and unlike charges will attract each other, right? And like charges will repel each other. So what is the magnitude of force according to the Coulomb's law? The magnitude of force is directly, we said that the force is directly proportional to the product of charges q1 into q2, and inversely proportional to square of distance. So here we use the proportionality constant, that is called K, which is q1 into q2 divided by r square. So what is the value of K? So we write the value of K is equal to 1 upon 4 pi epsilon naught, which is equal to 9 into 10 raised to power 9. Okay, 9 into 10 raised to power 9 Newton meter square per Coulomb square. So that is important unit that you have to write, and epsilon naught is 8.854 into 10 raised to power minus 12. So these are the unit, and this is Coulomb square and Newton inverse meter to the power minus 2, or you can write in the Coulomb square per Newton meter square. For this is for the free space, and suppose if you are writing in the medium, then in the medium you will have to take the dielectric constant also, that is epsilon r. You can write in terms of k is equal to 1 upon 4 pi epsilon naught epsilon r. Okay. So, for example, if there are two charges, suppose a proton and an electron are placed at 1.6 meter apart, then find the magnitude and the nature of the force. If I ask you, suppose there is a proton, okay, there is a proton and there is a electron, and they are separated by, suppose, a distance of 1.6, then what are the force? Then force is nothing but 9 into 10 raised to power 9, and the proton and electron are having the charges 1.6 into 10 raised to power minus 10, that is the charge on the proton, and the charge on electron will be negative 1.6 with minus sign into 10 raised to power minus 19 divided by r square. So this is 1.6 into 10 raised to power minus 2, because it is 1.6 centimeter, and 1.6 into 10 raised to power minus 2. So when you will solve it, this 1.6 will get cancelled, this 1.6 will get cancelled, and you will get minus 9 into this is minus 25 Newton. So this is negative sign indicating that the force is attractive force in nature. The force is attractive force in nature. So this is the Coulomb's law that you should know. Okay. So just tell me once whether these points are clear or not. This is the normal form of the Coulomb's law. Now we have to also understand the vector form. So quickly comment in the comment section whether you have got all these points or not. And see, I am also assuming that you all are not from the electronics background. You might be having some other background also. So that is why I am also telling that everything in from the basic, because it is important for all of you, those who are not from the electronics background. For electronics background it is quite easy thing, but for non-electronics background the students should also understand this basic thing. And this is just the 12th, because the physics that will be asked will be on 10 plus 2 level only. Okay. Now suppose there are 2 point charges in the two dimension. If I have drawn here, this is x and y. Suppose this is 1 point charge, let us say q1, this is another point charge, let us say q2, and this has the distance with respect to origin as r1 and r2. Okay, this is having the distance r1 and distance r2, that is known as position vector. Now, what is the force between them? So this q1 and q2, because these 2 point charges are separated by some distance, so these two, because they are positive, so they will repel each other. Okay, so this will, q2 will exert a force on q1, and q1 will exert a force on q2. These are the point charges, and they have the distance, let us say vector r. We are actually going to write the force on in the form of vector. So force exerted on q2, okay, force exerted on q2 due to q1 will be force on 2 due to 1 is in the form of vector, it is k, and q1 q2 upon distance is r square. So that will be the same, this is the magnitude part, and the vector uh, along the line joining between the two charges. So the line joining is from the 1 to 2, q1 to q2. So you will write the vector from 1 to 2. That is also the distance from 1 to 2. This you can write as 1 to 2. these two, the distance between these two charges are r12. So if you want to calculate the force on 2, then you have to join the line from 1 to 2. So when I am joining from 1 to 2, I am getting this direction. So this direction I am calling it as AR12 cap. That is the direction of force. So that I will write in this form, AR12 cap, because I am writing the vector. So the vector will have magnitude and also the direction. So this term which is inside the bracket is magnitude, and this unit vector will tell you the direction. Now you can write this unit vector in the form of vector which is r12 divided by r12 magnitude. So the magnitude is this, so the vector divided by its magnitude. So now it will become the force on 2, force on charge 2 due to 1 is k into q1 q2 upon r12 square, and this r12, and this r12 denominator will become cube. And what about this r12? So this r12 is nothing but the displacement vector. This r12 is called the displacement vector, which is from which point to which point you are going. According to that you have to write. So displacement vector. So we are moving from which point to which point according to this notation, 1 to 2. So we are calculating the force on 2 due to 1. So we are actually moving from 1 to 2. So because we are moving from 1 to 2, my second point is final point and my first point is my initial point. Okay, so second point means you can say the vector r2, because I have already denoted it in the r2 minus r1, r2 minus r1. So this is the r2 vector, this is the r1 vector. So final point is my r2 vector and initial point is my r1 vector. So that is why I will subtract r2 minus i1 to get the displacement vector. So in this form you will write the Coulomb force, that is known as vector form. Similarly, you can also write the force exerted on q1. So force exerted on q1 you can write f12. F12, the same thing, you have to move from 1 to 2 now. So when force exerted on q1, so because we are calculating the force exerted on q1, we have to move from 2 to 1. So 2 to 1, so k q1 q2 upon 2 to 1. So 2 to 1, so r21 in now vector r21. So a unit vector from 2 to 1. So this k into q1 and q2, the distance between both of them are same, so the magnitude will remain same. That is, you can write r21 vector here and r21 magnitude, and this is also r21. So this r21 r21 will get multiply and you will get k q1 q2 upon r21 whole cube. Now what about r21 unit vector? Vector, this r21 vector is just opposite to the r12 vector. Okay, so this r21 is just opposite to the r12. So now you can calculate from r1 minus r2. And how do you calculate the r1 and r2? So that r1 is nothing but the position vector. So if this r1 is having suppose coordinate x1 y1 z1, then it is x1 ax cap plus y y1 ay cap plus z1 az cap. And what about r2? R2 is x2 ax cap plus y2 ay cap plus z2 az cap. So these are the position vectors. So r12 and r21 are the displacement vector and r1 and r2 are the position vectors. Okay. Now we will discuss electric field intensity. So how do you define the electric field intensity? So how do you define the electric field intensity? The electric field intensity, which is denoted by E, is nothing but force per unit charge. Force per unit charge. Okay, that is given as E is equal to F divided by Q, the charge Q. Okay, and the formula for this would be, if you want to calculate for any point charge, then you can calculate. Okay, I will write it, don't worry. So for now, this is the force per unit charge. Force we will calculate from the Coulomb's law, and then we will divide it by the charge at the point where we want to calculate the electric field. Okay, I will tell you with the example. Okay, suppose I will take one example that 2 microcoulomb and the 8 microcoulomb are placed at 12 centimeter apart. So we have to find, suppose one example I am taking, these there are two charges, 2 microcoulomb and 8 microcoulomb, and they are 12 centimeter apart. Okay, they are 12 centimeter apart. Find the position where the electric field intensity will be 0. So we have to find the electric field intensity where we have to find the point where the electric field intensity is 0. So let us say this is the point where the electric field intensity is 0. So suppose this is the distance x. So this distance will become obviously 12 minus x. Now we want to calculate the electric field. So it is k into 2 microcoulomb, that is 2 into 10 raised to power minus 6 divided by x square. And because of this 8 microcoulomb, this is k into 8 microcoulomb. So 8 into 10 raised to power minus 6 divided by 12 minus x whole square. Okay, so it will get cancelled and we will get 12 minus x upon x whole square equal to 4. Okay, so or we can also write 12 minus x upon x equal to 2. So we will get 12 minus x is equal to 2x. So x equal to 4 centimeter we will get. So this is the point where the electric field intensity is 0. This type of question is generally asked in the such type of competitive exam. Whether if you are saying about any other competitive exam which has the subject as a physics, like a JEE or the NEET exam or any other exam, basic physics are there in their syllabus, then this type of question they generally ask. Whenever there are two point charges, those are positive. Remember, when there are 2 point charges, they are positive, then the electric field will be 0 only in between the two charges in the same line. Okay, that is, this point P will exist only between these 2 point charges. Suppose one is positive and another is negative, then the point where the electric field will be 0 will be always near to the small charge and outside the both of the charge. Okay, both of the charge, where that in that case the point where the electric field will be 0 will not exist in between them. In such cases the electric field will be 0 in the outside of the line joining, and near to the small charge. Okay, near to the small charge. So remember these points. And yes, electric field due to the point charges, I had written how I have written this. So I will write it here, that electric field due to point charge. Okay, electric field due to point charge, E is equal to K Q divided by R square and vector R, if you want to write in the form of vector R. So here actually I have divided by Q because the force will be like this, Q K q into q1, there are two charges, q into q1 and divided by r square, so that q will be getting cancelled. So in the denominator we have q, so this q and q will get cancelled, so we will get kq by r square. So kq by r square is nothing but the electric field intensity due to a point charge, kq by r square. And always the electric field is in the radial direction, in the direction of r, where you will have the force, the direction in which you have the force between the charges, the electric field will also exist in that direction. Suppose if the charge q is placed at the regular polygon, okay, if suppose the electric field you have to calculate, and suppose these are the regular polygon you are getting, like a triangle, like a square, okay, and suppose pentagon, they all have equal sides obviously. So in all such cases, if suppose there are charges placed, that is the plus q plus q plus q, and here also the charges plus q plus q plus q and plus q, and here are the charges plus q, that is plus q plus q plus q and plus q. So in all these cases, at the center, if they asked about the electric field intensity, then what will be your answer? Then what will be your answer in all these cases? In all these cases, so here the direction of electric field, because of this is the positive charge, so from the positive charge electric field is always outside, so this is outside. For this also the electric field is outside, and for this also the electric field is outside. So now if you will calculate, because the distance is same from all, so when you will calculate this, like this is E1 and E2 and E3. So this is the E2 and this is E3. So suppose if you calculate, this is suppose as a theta. So this angle is also theta. So now this is E2 cos theta, and here you will get E3 cos theta, because the angle will be same, because it is a regular polygon of equal sides. So it is E3 cos theta. This cos theta component will cancel each other, and here you will get E2 sin theta plus E3 sin theta, and both the value will be same because the distance from the vertex is same. So that is why it is nothing but the 2e2 sin theta. And because it is equilateral triangle, this is nothing but e2, because sin theta is 30 now. It is equilateral triangle, so the complete angle is 60, this small angle is 30, so it is e2. And E2 and E1, because this distance is same, so E2 and E1 are opposite, so they will also cancel each other. So you can say that the net electric field at the center will be 0. Net electric field at the center will be 0. Similarly here also it will happen. Because of this positive charge you will calculate the electric field will be in this direction, and because of this positive charge you will calculate the electric field will be in this direction. Both are having the same distance, so they will cancel each other. So here also the electric field, because of this point charge, will be in this direction, and because of this point charge it is in this direction, so again these two will cancel each other. So the net electric field in all the three cases which I have drawn will be 0, right? So you can calculate it. Here also when you calculate, the direction would be cancelling each other. Here will be the directions, the angle you have to calculate, then as we did in the case of triangular, you will get the same thing, and then net will be cancelling each other. So whenever there is a regular polygon and the charges of equal magnitude are placed at the vertex of a regular polygon, then the net electric field at its center is always 0. Now this question we will discuss later on. Okay, so now we will discuss about the electric field lines. Okay, what are the electric field lines? So electric field lines is nothing but an imaginary line or curve drawn through a region of space so that the tangent at any point of it is in the direction of electric field. Okay, so electric field lines are nothing but the imaginary lines. No? It are these are imaginary lines drawn through a space, drawn through a region of space so that the tangent at any point shows the direction of point of it shows the electric field. The electric field or simply the direction of electric field. Okay, now like suppose you have drawn like this any curve. So the tangent to it, this will be showing the electric field direction, this will be showing the electric field direction, this will be showing the electric field direction. Okay, so this is at point P if I ask you, so that is the direction of electric field. At point Q if I ask you, then it is the direction of electric field. And if I at point R if I ask you, then it is the direction of electric field. Okay. What are the different properties of electric field lines? These are imaginary lines. They are curved. They can be curved or straight. Okay. They can be curved or straight. Okay, now the second, they are drawn in such a way that the tangent draw at any point gives the direction. So that is the main definition of the electric field lines. That whenever you draw a tangent, then it will give you the electric field lines. Okay. Then second point will be they are continuous in space. So that is they have no sudden breaks. So it is continuous in space. Okay, they are continuous in space, and also they never intersect with each other, so two field lines never intersect. Two field line never intersect. Then the fourth one is they start from the positive and they terminate on negative charges. So electric field line always start from positive and terminate at negative. So start from positive and terminate at negative. Okay, and if the field lines are straight and a charged particle is either at rest or initially moving parallel to the fields, then it will follow the field lines. It will follow the field lines when the charge field lines are straight. Okay, and there are more properties you can write that they contract longitudinally on account of the attraction between the unlike charges. Okay, and the density of electric field lines represent the strength of the electric field. So where the density will be more, the electric field is more. Okay, so that also can be the property of electric field lines. Now for example, that if there is a isolated positive charge, so if there is a isolated positive charge, electric field lines will be outside. So this will be like outside, like this. If it is a positive charge, then field lines will be always outside, like this. Okay, the point where the field is more, the density is more, that will be the having the more electric field. like suppose I increase the density over here, suppose I increase the density somewhere here, and there are 2 points. If I mention it, this is suppose point A and this is suppose point B, then the electric field at point A will be greater than the electric field at point B, the mod of it. The electric field at point A will be more than the electric field at point B, because the density of electron is density of electric field lines are more here. The density of electric field lines are more here. That's why the electric field will be more here. Now similar case is with the negative sign. So whenever there is a negative sign, this is the about positive charges, right? And when we keep the negative charge minus q, then all the field lines will be inward. Okay, so that these are the isolated negative charges. Now the two positive charges are there. Suppose there are two positive charges. One is plus q, another is minus q. Plus q, let us say both are plus q. Then what will happen? This, because this is also plus q, so the electric field lines will be outside. So these field lines will be like this. Because the electric field lines are outside, so it will be like this. Because they never intersect, so here also it is like this. They should not intersect. And suppose both are having same magnitude, so field lines are same here, you can see, but they are never intersecting. They are not intersect. So the direction of electric field, suppose if you want to calculate, then you can draw the tangent. So when you draw the tangent at any particular point, say P, the direction of electric field will be this. Now if there is a positive and negative charge both, if suppose there is a plus q charge and minus q charge, then definitely the field will start from positive and it will go up to negative, and you can draw like this, plus to minus, plus to minus, there is electric field charges, and this is plus to minus going, plus to minus going, this is also plus to minus going, it is plus to minus going, and here it will be entering like this. So these two are leaving because it is positive charge, and these are entering because it is negative charge. And if you again want to draw the electric field lines, so at any particular point P, you can draw the tangent. So the direction of electric field is this. Now the electric field line can be parallel also. So electric field line can be parallel like this. Okay, and the electric field line can be in this form also, that here it is more dense in this region, it is more dense at point P, and at point Q if I am asking, then electric field at point P is again greater than the electric field at point Q, because the density of electric field lines are more at near to point P than the Q. So these are the different properties of electric field lines. And what are the electric field lines that can never exist? Okay, field lines that cannot exist. So field lines cannot be circular. It should never be a circular. So these will not exist. Okay, it should not be a circular. So it cannot be like this also. Positive, then negative, it is showing the circular lines. Then it is here. Okay, so these type of fields will also not exist, cannot be circular. It can never go from negative to positive. So if you will see negative to positive, suppose this is a plus 10 coulomb and this is minus 10 coulomb, then if you will see the electric field lines like this, then this will never exist and they will never intersect. Okay, so this is the second diagram, this is the third diagram, and they will also never intersect. Suppose the electric field lines are this, then that is also not correct. So they can give you the four different options and they will ask you that what are the field lines that may not exist. So you have to identify that which one will not exist. So remember these points, that which electric field lines cannot exist if it forms a circular loop, if it is starting from negative to positive, and if they are intersecting, then these type of field lines cannot exist. So you have to choose according to that. Now there are some important point about the electric dipoles. So what are the electric dipoles? An electric dipole is a pair of equal and opposite point charges separated by some small distance. So there is a 2 point charge like this, the plus q and the minus q, and they are separated by some small distance, let us say d. Then this is called as the dipole. Okay, so what is the dipole moment or electric dipole moment? So dipole moment is a vector quantity, and that vector is nothing but a q into d. The magnitude is q into d. The direction of electric field, according to that, the dipole moment is opposite to that. So it is from negative to positive. So the dipole moment is from negative to positive. The direction from minus q to plus q is said to be the direction of dipole moment. Okay, minus q to plus q is the direction of dipole moment. Electric field will be having the direction from positive to negative, but the dipole moment will be from negative to positive. The midpoint will be, means at d by 2, that will be called as the center of the dipole. The what is the unit of this dipole moment? The unit of dipole moment is coulomb meter, as the charge into displacement or distance between them. So the field of an electric field at a different point. So these are important points about the dipoles, that is known as equatorial line, and these are known as axial lines. Suppose there are two charges here, minus q and plus q. So these are called as axial lines. These red dotted lines are known as axial lines. Axial. Axial lines. This is minus q and this is plus q. And this is known as equatorial line. This perpendicular line is known as equatorial line. And when you draw this connect, you can connect them. This is exactly at the midpoint. Okay, so the complete distance is, suppose, d. Let us take it as a 2d. Okay, just for simplicity, because it will give you the simple calculations. So d and t, so we are taking the 2d this time. So here also we can write this 2d, so the value will become 2qd. So let me write in this way only. So 2 into q into d. Now, what are the different points where the electric field exists? So the equatorial line, the electric field at equatorial line. Okay, at equatorial line. electric field is 1 upon 4 pi epsilon naught and minus p, that is the dipole moment, divided by r square. What is r? R is this height. This height is r. R is this height. So r square plus d square to the power 3 by 2. So this is the for see sometimes in the Airport Authority of India they direct ask the question based on this diagram they will give you, or they will give you the same thing in the form of a statement, and they will give option in the form of expression. So I have personally experienced that in my time also they have asked the questions related to some line charges, and what is the electric field due to the line charges they asked, and for that you should know the formula. You cannot derive it there because you will not have the time more than 1 minute, so in the within the 1 minute you will not be able to derive it. So you have to remember all these formulas to answer such type of questions. So they can ask you the question, and they can give you the two, they can say that one there is a one dipole, the distance between them is 2d, and you have to tell the electric field at the equatorial line at distance r. So that is 1 upon 4 pi epsilon naught minus p vector p upon r square plus d square to the power 3 by 2. Okay. If that is the short dipole, if they say short dipole in the sense when the distance between them is almost negligible, so when you will neglect it, you will get if the d is negligible. Okay, if suppose d is negligible, that is known as short dipole. Okay, short dipole. Then this formula E equivalent will become 1 upon 4 pi epsilon naught minus P upon this D is negligible, so R square will be left. So square square will get cancelled and we get R cube. Okay, now let's calculate on the axial point. So electric field in the axial point is just twice of the equatorial, 1 upon 4 pi epsilon naught, 2p, this is plus 2p, that is the dipole moment, and the r, 2pr, and the dipole moment is a vector quantity, divided by r square minus a square. Sorry, d square. R square minus d square. And whole square. Yes, whole square also. R square minus d square to the power whole square. And when again for a short dipole, that is if the d is negligible, then it will be again r cube. Then the E axial would be this d square will get cancelled or negligible. So r square will become r to the power 4. So it is 1 upon 4 pi epsilon naught. And because there is also r in the numerator, it will get cancelled and we will get this. And here you can see that this is nothing but the, for a short dipole, the axial electric field is twice of the equatorial. Axial electric field is twice of the equatorial with minus sign. With minus sign. Okay, is it clear up to this point? Then what are the other important points? Now you will calculate the electric field intensity due to finite line charge. Due to finite line charge at perpendicular distance. At perpendicular distance. So electric field due to the line charge at perpendicular distance. Suppose we have this as a line charge and we want to calculate in the perpendicular distance like this, somewhere here. Okay, so that is suppose the angle theta 2, that is suppose the angle theta 1, and the line charge density, because it is in the form of line, so there is a charge distributed, so the line charge density is known as lambda. Line charge density is lambda, and this perpendicular distance is r. So in such case, the electric field is given by 1 upon 4 pi epsilon naught, that is k, lambda upon r in bracket sine theta 1 plus sine theta 2. Okay, this is the theta 1 angle and the theta 2 at the perpendicular distance. Okay, suppose there is a circle. Now we want to calculate the electric field due to circular ring. Okay, electric field due to a circular ring. As I told you that this was the question that was asked directly in when I had given the exam. E due to circular ring. So E due to circular ring, we are having the charges in the form of a ring. The charges on this wire in which is forming a ring is having certain radius, that is r. Now what is the electric field at the center of uniformly charged distributed ring? So obviously the electric field will be 0, because in the center the electric field will be 0. So these are the formulas. Okay, now electric field, suppose you want to calculate somewhere, it is suppose semicircular. Okay, electric field due to semicircular, E due to semicircular ring, which is placed in this form. Suppose these are the ring in the form of semicircular, and we are asked to calculate the at the center, that is the here. Now what will be the electric field in this case? Yes, so electric field will be, this time it is lambda upon 2 pi epsilon naught r, and the direction will be along the negative y, along negative y. Why we are calling negative y? Because when you suppose divide here one part and you will calculate the electric field some in this direction, similarly uniform and equal and opposite side you will take this. So there are two components it will generate. This is the one component, this is another component. So these two cos component will be in the opposite direction, so they will cancel. So all the resultant electric field will be in the negative direction. So if this is the y axis and this is the x axis, the electric field will exist only in the negative direction, negative y direction. Similarly, you can calculate the electric field due to the circular arc. For that, you have to take, let us write here, electric field due to the circular arc. Okay, the diagram, let's draw this diagram in this form. This is the circular arc, and we want to calculate at this point. This is the charge ring and having the angle theta. Then what is the electric field? In that case, the electric field is lambda. This is the same thing, lambda upon 2 pi epsilon naught r, but here we need to multiply with the sine theta by 2. And here also the direction of electric field will be in the negative y direction. Okay, so these are the formulas that you should remember to solve the problems directly. Otherwise, you will face problem to solve it. You will not be able to solve it within the time limit. Okay, these are some important formulas for electric field. in the different situation, whether it is a circular, whether it is a form of ring, whether it is a straight line, or it is circular arc. So these are the points for which you can calculate the electric field. Now there is a very very important point, that is about the Gauss law. What is the Gauss law? So Gauss law says that total flux passing through closed surface, right? So total flux passing through closed surface, through closed surface is equal to the charge enclosed by closed surface. Okay, so that means the flux is I and the charge enclosed is Q enclosed and divided by epsilon naught. Because 10 plus 2 level we write in this form, charge enclosed divided by epsilon naught. Now how do you calculate the flux? Flux is integration over the closed surface, E dot ds. We will write E dot ds, that is the closed surface. Integration over the closed surface, E dot ds, charge enclosed. Okay, suppose how do you calculate the flux? So there is a suppose electric field lines. So these are the electric field lines. Okay, these are the electric field lines. And suppose when these electric field lines are not passing through any surface, that will not generate the flux. But suppose if this is passed through some surface, suppose you have kept the some plane over here. So electric field line passing through this. So what is the perpendicular surface to this? This is suppose ds, and the angle between the electric field line, which is horizontal, and this is angle theta. Then the flux, the xi, is nothing but the E dot ds. Okay, that you can write it as E ds cos theta. The ds is having this direction, this is the small surface ds. And now if you want to calculate the electric field passing through whole surface, then to calculate the flux through whole surface you have to integrate it. Integration over the surface, E ds cos theta. Okay, here we are saying closed surface. Okay, here we are saying the closed surface. Remember that in the Gauss law we calculate the flux through the closed surface. But what is the definition of the flux? The flux is not always calculated in the closed surface. In general, the flux is calculated as integration over the surface E dot ds, or you can simply write this also, the flux through the small surface. Flux through the small surface design. This is design. And now when you integrate it, you will get the total flux. That is the total flux. Gauss law is true for any closed surface. It does not depend upon the shape. It is not necessary to have the symmetrical shape. Okay, Gauss law is true for any closed surface. Okay, also that electric field because of the charge sheet. Suppose you have any charge sheet. Okay, suppose you have any charge sheet like this, any plane, which is suppose z is equal to 0 plane, then the electric field at point P, which is in the positive z direction, this is the positive z axis. Okay, this is the positive z axis. So at point P, if you want to calculate, then electric field is given by E is equal to rho upon 2 epsilon naught, where the rho is surface charge density. That is rho into rho divided by 2 epsilon naught. And because you are moving in the positive direction, the point of interest, the point where you are calculating the electric field is in the positive direction. So that is why the direction of electric field will be positive z. Okay, suppose you are calculating the electric field at the negative direction, that is q, somewhere here, which is in the negative z direction. So because you are moving from the infinite sheet to this point q, the electric field would be rho upon 2 epsilon naught minus a z. So when you move in the negative direction, it is minus az. When you move in the positive direction, it is plus az. Okay, so there are some important point like electric field passing through the uh, or electric field due to the conducting and non-conducting shell, you can say. Electric field due to uh, electric field due to a conducting sphere. The spherical one is very very important. Suppose there is a sphere. Okay, there is a sphere, and because it is conductor, it has the charge on the surface of the conductor. So it has charge which is having the radius r. Now we want to calculate the electric field at any distance r greater than capital R. Means somewhere in the outside, somewhere at point P, which is outside. The small r, where our point of interest lies, is outside the conducting sphere. So in this case, the electric field is same as the equivalent to the point charge, kq by r square. The charge is q. The total charge on the sphere is q. So the charge, it will act as a point charge, and the formula will be kq by r square. The difference is the q is not a point charge. It is acting as a point charge because you are lying outside. So when you see the any sphere from the far away from the sphere, then the sphere will look like a point. So that is why the formula is similar to the point charge you are keeping at some location. So but it is not, it is just I'm telling to memorize the formula, but here the charge is not a discrete charge, it is a distributed on the surface of the sphere, and that charge you can calculate by using the surface charge density. Surface charge density is nothing but the charge per unit area, and here the surface area of the sphere is 4 pi r square. So if you multiply the surface charge density rho with the 4 pi r square, you will get this q which I have written. But in the case of discrete point charge, the q is directly given in the form of 1 microcoulomb, 10 microcoulomb, like that. So that is the difference. Now when you calculate r is equal to capital R, means that your point of interest will be now at somewhere on the surface, then the electric field will be k. Here this is kq by small r, this is kq by small r square, and this is kq by capital R square. Because this r is the distance, now this small r has become capital R. Now when you try to find the electric field inside the sphere, then the electric field will be zero, because the charge does not exist inside the closed surface or inside this conducting sphere. So we can say that, okay, we can say that the total flux passing through the closed surface is equal to the charge enclosed, and because there is no flux passing through this closed surface, so electric field will also be zero. Because the charge does not exist, the electric field is zero. So that is about the conducting sphere. Now in case of non-conducting sphere, when there is a non-conducting sphere, okay, like this, suppose there is a non-conducting sphere. So in that case, the charge will lie inside the sphere. So the charges will lie inside the sphere. Okay, so from this center, suppose the radius of this non-conducting sphere is r, then in the same three cases, the electric field will be r greater than r, the electric field is same. There is no difference, kq by r square. Then r equal to r, there is no difference. So kq by capital R square. And this time, because the charges are present inside, the conducting sphere, the electric field will be r less than r. The electric field will be k q into small r divided by capital R cube. Okay, this would be the electric field. So if you will draw the graph in the both cases, then you will find very important graph, because this type of graph is generally asked in any exam. So here you can see that in the first case, when we are inside, that means at r equal to 0, this is the electric field, this is small r. When r is 0, that means we are at center, so the electric field is also 0. When we are inside the sphere, the electric field will be 0, because r less than r, the electric field is 0, so it is 0 up to this point. Now when r is exactly equal to r, the electric field suddenly increased to the point having the value k cube by r square. Now after that, when you increase the value of r from the capital R, if you further increase, the r is increasing, so electric field will be decreasing, so it is a decaying function. So this will be the plot. Now similarly, in this case, when the r is less than r, here you can see that the E and r is having the direct relation, so it is a straight line. Then at r equal to r, it has some finite value, and after r it will decrease. So the same thing, but the difference is that here in the beginning they are not 0, they are following the straight line, because E is directly proportional to r when r is less than capital R. Okay, so these are the conducting and non-conducting sphere. So this is electric field due to non-conducting sphere. Now let's look at the some of the questions that was asked related to this. Okay, and from the particularly from the subject physics. Okay, so this is the question that was asked in your say from the law of motion, that will be discussed in the somewhere law of motion. So remember that this is one of the important topic, the law of motion. The law of motion questions, that is the previous year question. Now which of the following quantity is a vector quantity? So out of which one is a vector quantity? So this is simple, vector and scalar definition you should know. So this is nothing but your area. Okay, area is a vector quantity. Okay, area is a vector quantity. Now this is the question from the gravitation. So when we will discuss the gravitation, we will talk about this. This is all about the gravitation. This is also gravitation. Now what will be the answer of this question? Ampere circuit law, because this is a basic Maxwell equation, so I would like to answer here. What is the Ampere circuit law out of this? So we know that according to the Ampere circuit law, integration over the closed loop H dot dl, integration over the closed loop H dot dl is equal to current enclosed, right? So Ampere's law says that integration over the closed loop tangential component of H dot dl is equal to current enclosed by that closed loop. So when we will apply the Stokes theorem, so when we apply the Stokes theorem, here we will get the surface integration curl of H, and then it is dot ds because the closed loop has been converted into the surface, and this we can write as integration over the surface. This is the conduction current. So conduction current density can be written as conduction current density dot ds. So when we compare it, we will get the curl of H is equal to JC. So that is your Ampere circuital law. But because here you can see that in the form of B it is written, so we should also know that B is equal to mu into H. So we have to multiply mu both the side. So we will get mu into H, and here it is mu into JC, and it will give you the value as curl of B equals mu into JC. So that is your answer, which is option number A. So Ampere circuited law, it is based on the Maxwell equation. Now we have, according to the Gauss law, the electric field. See, according to the Gauss law, the electric field due to the infinite long wire. Infinite long wire, what is the electric field? So due to the infinite long wire, we have already written the expressions. It is not necessary to answer from the Gauss law. We have said that if there is a finite length wire, then how do you calculate the electric field at any point P? Suppose at any point P, if you want to calculate the electric field, then this electric field is nothing but I upon 2 pi r. Okay, I upon, sorry, this is the, yeah, electric field we want to write now. Wait. So electric field line, because the infinite long wire is there, so we can write in terms of lambda actually. We have written in the form of lambda, not in the form of I. I is actually basic in the form of current. Na? So electric field due to the infinite long wire at any point P is lambda upon 2 pi epsilon naught. That I had written in the form of current. That was the magnetic field. So this is the, in the normal direction. The electric field exists in the normal direction. That is this line, this direction. So lambda upon 2 pi epsilon naught r. So E is inversely proportional to R. So answer will be option A. So that is the question from the Gauss law, or you can say simply from the electrostatic. Okay. And if you want to see more questions, this is a rectangular loop. So again, this is the current carrying a straight wire. So this is the magnetism, and this is a Fermi direct, that is the semiconductor physics. So you have to study the semiconductor physics as well. And this is again the gravitational motion in an orbital motion, the angular momentum vector. So this is angular momentum vector is always a perpendicular to the orbital plane. So these are the questions that energy is stored in the capacitor. Okay, so energy is stored in the capacitor, and we have to find the power. So energy stored in the capacitor is uh, half cv square, right? Energy is half cv square, and we want to calculate the power. Power is energy per unit time. So you can write 1 by 2 cv square divided by time. So 1 by 2, the capacitor is having the capacity 50 microfarad, 10 to the power minus 6 volt square, so 3000 whole square divided by time, that is 2 millisecond. Okay, so from here you can calculate. This is your 50 into 10 raised to power minus 3. It will get cancelled and it will be minus 3. And it is 6 into 9 divided by 4. So because it is asking the kilowatt, so this will give you kilowatt. So this is nothing but a 450 divided by 4 kilowatt. So it is around 112. Na? Okay, so from here you can give the approximate result because it is asking for close answer it is asking for, so you can give the close answer. It is not necessary to calculate accurate answer, because again I told you in the previous session that is somewhere in 1 minute you have to solve. So 112, so you can answer as 150. Okay. Now the earth magnetic field is given, so it is a magnetic induction. So that means electromagnetic induction. Electromagnetic induction you should cover. And energy of a photon of wavelength 5890 emitted by sodium. So E is equal to hc upon lambda, blank constant, hc, c upon lambda. So this basic equation of this light generally comes photon energy, and this is the spin constant. So this is on the topic of the Newton law of motion, that is NLM, Newton law of motion. That is the topic which you should cover. And the distance between sun and earth. So this is again the question from the gravitation. So the gravitation question, that is based on the Kepler's law. Okay, that is the based on the Kepler's law. Okay, so Kepler's law, T square is directly proportional to R cube. So T square directly proportional to R cube. Based on this, you can solve. This is the radius, this is the time period. What will happen if you reduce the radius of by half, then what will be the number of days in 1 year? Because in 1 year on the earth, we have 365 days. Similarly, you have to calculate. Which of the following is not a Maxwell equation? What are the Maxwell equation? Four Maxwell equations are: the divergence of D is equal to rho V. Okay. Then the divergence of B is always equal to 0. Okay. And third is divergence of B, curl of B is equal to mu J plus mu into JD, JC plus JD. Is not a Maxwell equation, na? So, and the fourth is the curl of E is equal to minus del B upon del T. So this is the Maxwell equation, and this is also the Maxwell equation, and it is written about divergence of B is equal to this, and the curl of H. Okay, this is written in the form of H. So it is written in the form of H. So that's not no need to write in the form of B, because just now we write na. So curl of H is equal to J we calculated for the static field. Now for the time varying field, this is JD, and this JD is del D upon del T, that is the displacement current density. So del dot B should always be 0. So that is why we will say that our answer will be this B. That all one A, B, and A, C, and D are the correct options. Okay, so this is the question from the
This we can
again
take, sir,
Newton law of
next.
motion. So Newton law of motion we have to cover,
Sir,
and that is the boundary condition problem. Okay, the boundary condition problem from electric field. And this is again the question from the parallel plate capacitor. So parallel plate capacitor, you have an idea. And a particle of 15 kg is a moving in a constant acceleration, starting from the rest, the momentum and the velocity. So you have to fill this data. It is given in the question. So this is basic question of the law of motion again. The momentum is P is equal to mv, and the acceleration is given, so A is equal to V upon T. So this two formula you should know. So first of all, you will, because acceleration is given, so you will calculate the velocity. So where, suppose for one question I am calculating, so V is equal to A into T. A is 3 and the time is 0.5, so it is 3 by 2. Velocity is 3 by 2. So when you will calculate, V A is equal to dv by dt, right? Yes. So this is 80. So 3 by 2 is the velocity. So here we will write 3 by 2, and momentum is m into v. So it will be, the time is 0.5 now, and it is acceleration only, right? So yeah, in this way, you will put the value of velocity, you will put the value of mass and velocity, you will get the momentum and the velocity you have calculated. So you have to fill these four tables in, and the options were given. Okay, the options were given with this data. So from that you can calculate. Circular coil of wire consisting of 500 turns, magnetic field at the center. So magnetic field, that means magnetostatic we have to study. Magnetic field, again amplitude of magnetic field, so again you have to calculate the electromagnetic wave. Okay, electromagnetic wave, because it is asking about both magnetic field and electric field of the electromagnetic wave. So what are the important topics you have got till now? Electric, electrostatic, magnetostatic, electromagnetic induction, electromagnetic waves. And then again electromagnetic wave question is there, so you can calculate this. And again the Newton law of motion, that is based on friction. Okay guys, so thank you for watching this session, and I hope that this session is useful for you, that what are the topics you need to cover. I have covered some electrostatic part, but there are few more questions that I have shown you to give you an idea that in the, suppose up to the next class, what you should come prepare with. Okay, so what are the topics like Newton law of motion you have to prepare with. So we will take the question on that. We will also take the theoretical things about those questions. Okay, thank you for watching this session. Don't forget to subscribe. Okay, so in the next class, we will be discussing about the Newton law of motion, especially because as I have shown you that there are few questions from the Newton law of motion, so we can discuss the Newton law of motion as well. Thank you.